Thank you so much. I'm so excited to be here or wherever we all are. I just put a link in the chat that has a document with a few links in it. So hopefully we'll be able to use that for participation today. But please let us know if you didn't see that link. So the title of this talk is Demystifying the Machine. And what I mean by that is trying to make sure students know what's going on when they're actually running code. And of course, that's our goal. Of course, we want them to know what's actually going on when they use a statistical method. And that's always what we try to do. And I've tried to do that lots of different ways in my courses. But I want to talk about one specific course that I taught last fall where this felt particularly urgent. So this is a second level applied statistics course at a liberal arts college. I teach at Wellesley College, which is a liberal arts college for women. That's a 4-year college. And this is the second course in our applied sequence. So we talk about hypothesis testing at a deeper level and non-parametrics and modeling. This course was once based on the Statistical Sleuth textbook by Ramsey and Schaefer, although I've been getting away from that lately. And we're now also including data science topics in this course, such as data wrangling in R. The prerequisite is any flavor of intro stats, which has a broad range. Like many colleges, we have intro stats in psych and econ and math and biology, all different departments. So one of the purposes that this course serves is to bring students together from all these different courses that have different emphases and also different levels of statistical insight, and get them all on the same page and teach them R so that they can move on in our statistics sequence. So it's a very diverse class. But it changed a lot in fall 2019. Now, I know that many of you teach at colleges much larger than mine, but for us, a class of about 25 is typical for a 200 level class like this one. But in fall 2019, because there's only a couple statisticians and there were some leaves, because more departments started counting this course, because we invented a new data science major, and for lots of different reasons, there was a huge demand for this course. And so we decided to as a trial, increase the enrollment to 45. So that's fine. I was excited about it. It's an experiment. We started to try to figure out what resources were available to try to adapt. What were we going to have to change in order to accommodate a larger class size? So the first thing we found out is that the room I was assigned didn't have enough chairs, so we dealt with that. I had to get some extra TAs. We did that. Turns out chairs aren't helpful unless you can see the board. We got some new boards. The IT people even gave me a ball with a microphone inside to toss around the room. So that got some laughs, but turns out not so good if you have water bottles and laptops around. But what I was more interested in is what we should actually do. How should we deliver the content? At a liberal arts college, we're used to, or at least in my classes, I'm used to most students speaking during most classes. I know that's not always the norm at many colleges, but for us, having the students speak out loud as a way to think through their ideas and really solidify their understanding is a key part of what we're trying to deliver. But even in a much larger class, of course, that's what we want to do. We want the students to be thinking through the ideas and understanding them in a deep way, not just writing down whatever we say. So I wanted to do some group work. This picture here is from DataFest a few years ago, but we want students to be working in groups in some way so that they all have a chance to speak. But then, of course, the question is, what should they actually do when they are working in groups? And there's lots of different things that I've done before, and many of you have done before. When students are working in groups, you can begin your homework a little bit. You can discuss an example. You can edit some of my code and see if you can get it to run. There's one favorite example that I know is very popular to show students some pictures of graphics, of scatter plots, and have them guess the correlation. And that one actually inspired me a little bit as I figured out what the most effective group work tool was to engage everyone in this particular class. And that was to try to get students to develop methodological solutions before I told them what the most common method was. And that's what this talk is about. I figured out in this particular class, and I guess I think in probably many classes at the intro level as well, or classes of any size, one way to engage students and get them to really think is to have them do the group work before the introduction of new material rather than after. So I'll show you what I mean. The very first class, actually before I even talk about the syllabus, I introduced a data set that I like to use throughout the class. I'm guessing many people have heard of this one. Albert Kim posted this one about OkCupid. So this is dating profiles from San Francisco from several years ago. It's a big data set, it's a real data set, it's messy, and the students really like it because it's about dating profiles. So what I want you to do, if you click on the link that's in the chat window, you should be able to click on this link that says modeling example. And from there, submit response. Let me just show you. Here, I should be able to put this particular link in the chat as well. I'll try to do that directly. Okay, so here is this link that I'm showing you right here. This is the handout that I give the students in the first day. I've actually done this one for a few years. And the first time I did it, I was more inspired and I cut up the pieces of paper into little slips, but I didn't do that this time. I just printed them out. So these are the first 9 rows of the OkCupid data set. You can see there's a few variables here. Purposely, these are not, this is not data in a rectangle, right? This is a bunch of dating profiles. And while I talk more about this, I want you to do what the students have to do and try to guess the income of the person in profile 9, just based on the information we have here. So there's a link for that as well to submit your answer. Pretty please try to make them easy for me to clean so I can show you a histogram of your answers, but if it doesn't work, I think we'll all be fine. Okay, so what do I want to say about this one? Well, so as the students think through this exercise in the very first day, they've had some exposure to statistics before, but usually kind of plug and chug statistics. So what they realize they have to do is consider the context. There's going to be some cleaning that has to be done, right? So the students realize that the data has essays in it, right? It has text. The numbers aren't necessarily all clean numbers. There's a lot of categorical variables. As they look at the incomes, they see outliers. I hope they start to think about the survey question design. I hope they start to think about the fact that there's all these people who went to space camp. Are you seeing that? I'm trying to see if I can look at your responses as you type them in, right? Yeah, I see responses coming in. Right, who are these people who went to space camp? What do you think OkCupid did? Maybe people weren't typing in free responses. Otherwise, would so many people have gone to space camp? We start to think about visualization. I see students sitting there trying to write down, draw a picture of what the data would look like. They're all making some assumptions as they move forward. Some of them start drawing rudimentary regression trees. They don't know what that is necessarily. Most of them don't, but they're making non-parametric models. They also start to worry about overfitting. I see the students in the first day of this class getting worried. Well, just because this other profile has the same age doesn't mean that they would have exactly the same income, right? So they've already got that idea. The idea that text is data. The idea that you are missing some essays, you're missing some responses. What are you going to do about that? All these things come up right away when you are trying to make a guess. So let's see. Let me see how many responses I have. Do I have enough to make you a little histogram? I think I do. That's enough. So let me take a second, see if I can quickly do this. And feel free to make your guesses continue to come in while I try to make a picture for you. So we've got some outliers here. So let me show you what this looks like.
We don't see it yet. Oh, there it comes.
Maybe
Okay.
there it is. Is it there now? I think I have to refresh this screen.
Yeah, there it is.
You see that? Okay.
Yes.
So I see outliers. I'm not going to take the time to try to make it look better because I think you got the idea. That maybe one person from there thinks that this is like a million, right? Maybe it's worth it. Let me try really quick. Hang on. Let me give it more breaks. I learned from online teaching, like we all did this semester, that I need more than one device at any moment. Okay, hold on a second. Try one more thing and then I will quit this. There we go. That's only slightly better. That wasn't worth it, but I'll show it to you anyway. There we go. Get rid of the old one. Okay, there we go. You can see that. Was that worth it? I don't know, but you participated, right? You see what the students do. Let me reshare or present. So the students make their guesses and we look at them. And what I actually did in the class in the first day was write it on the board and try to get them to see and discuss the reasons for their guesses, right? But you can see that within this group, right, somebody liked that outlier, right? Somebody thought that this person makes $1 million and that is a defendable response. But it's certainly not the case that everybody chose the same answer because you have to do some model selection, right? Not every model makes sense. And or not every model is obviously the right answer. And this is a stage where the students haven't even understood the idea of a model yet, but already we're seeing that everybody's got their own model. So then I show them a series of slides with some different visualizations. This is just one. We have a discussion. I think it's one of the most valuable discussions. What is space camp? Is it real, right? And a lot of the students actually think that there's something called space camp that must be in California, and a lot of people are typing it into free responses, as opposed to OkCupid has a tongue-in-cheek option on their education answers. And then once we realize it's a tongue-in-cheek answer, what are we going to do about that, right? How do we incorporate that into our data analysis? So what's the moral here? And by the way, you've got an answer to the $150,000 for those of you guessing. So the moral on this very first day is that a model is some method or algorithm, and no matter how fancy its name is, even if you were trying to sit there and write a regression, it comes from somebody, maybe a long time ago, maybe recently, who had the same goal you just did. They're trying to make a prediction, but they faced the same obstacles you faced, except you have an advantage because you can actually see the data set, right? So I find a lot of the students who come from an econ background sit there trying to run a linear regression without a computer and don't really know how, because that's what they think they should do when they're making a prediction, and that doesn't work, right? So I'm trying to motivate the idea of a model, and I find this is effective for inspiring them to keep going in this course. So we move on then, this is actually just the third day of the course, to hypothesis tests. And so I put up this picture of Muriel Bristol, who was the original lady tasting tea. I'm guessing many people have heard of this example, but basically Muriel Bristol was at a tea party in graduate school with Fisher, and she claimed that she could tell whether a cup of tea was poured milk first or tea first. And we read this little article about how she was an algaeologist. She had a PhD in algae, which is kind of neat. And I tell the students, okay, so imagine you were at a party and somebody proposes that they have some party trick, right? There's 2 ingredients in their beverage and they can tell which one was poured first, right? And they understand that. That is real to college students. And I ask the students, before we talk about hypothesis testing, to get into groups and each make a slide proposing an experiment that they might run at a party to figure out whether their friend had this skill to figure out whether some beverage was poured, say tea first or milk first. Now, this is a hypothesis test. Or it could be a hypothesis test. I'm not going to ask a room full of statisticians to propose a hypothesis test, because you know what that is. What I think is interesting is that these students who've already had intro stats often don't recognize that this is a hypothesis test. Maybe they've looked at the course outline, they know what we're supposed to talk about that day, but a surprising number of students actually reinvent a hypothesis test without realizing it, which I think is important. It says something important about where they usually leave even an excellent intro stats class and what they need moving forward from there. Many of the plans do turn out to be hypothesis tests. And then we look over graphics like this one. So here the x-axis is the number of cups the lady has to taste. And if you assume that she gets all but 1 correct, here's what the p-values would be. I've drawn a line at 0.05. And then I show them how many cups each of those groups proposed that the lady should taste. So you can see my students had the lady drinking a lot of tea, 80 cups, 40 cups, 20 cups. And I show them that, and not all of them, but many of them proposed that she should get all but 1 right. The p-values associated with the cutoffs in my students' experiments were not 0.05. Most of them were much smaller. One was bigger, but most were much smaller. And I think that drives home some important ideas as well. Before we talk about p-values in this class, before we talk about hypothesis tests, they already understand that you would need to come up with a cutoff if you're running an experiment for how to make a decision, and there's nothing special about 0.05, right? And I think the way that we all need to be teaching hypothesis testing right now is either not at all or with a lot of perspective on any kind of 0.05 cutoff, especially when teaching students like these who come from a variety of fields and maybe aren't going to be statisticians, but perhaps are going to use a lot of statistics and maybe be the ones standing up for 0.05 not being a strict cutoff. Also, some of the students don't propose hypothesis tests. Some of them say, you know, I don't think anybody could possibly tell which beverage was poured first based on my own experience. In other words, they're Bayesians, they have a prior. And I also like that discussion early in the course because frequentist statistics is not the only method out there. And it's nice to get that perspective into the students as soon as we can. That's a second example. The third one comes from much later in this course. So the way I develop modeling after the first day, we do hypothesis testing and some data wrangling, and then we go back to modeling. I teach some regression trees first because I think it's important to have a clear understanding of what modeling is, and they understand binary splits. And then we introduce just very briefly the idea of writing down an equation to relate predictors to an outcome. And then I show them this picture, right? So we haven't done much simple regression, maybe a couple minutes of it. We haven't formally done any multiple regression, and I show them this picture. So as I talk, please go ahead and fill in the response link. I ask them to get into groups and stare at a picture like this one and try to tell me what equation this is. Yep.
Casey, can I interrupt? That
Yeah.
response link we can't click on.
It should be in the same, if you have that link from the very first thing I sent out, it
Okay,
should.
I'll just repost that. Thank you.
Yeah, if you repost that. Yep, thanks for interrupting me. Let me redo this. Do you see it in there, Megan? Is it there? It should be the example 3 link in the document that I sent out at the beginning of the talk.
Oh, okay.
If you could repost it, Megan, that'd be great.
There it goes.
Okay, thank you. Okay, so I show them a picture like this one, and I ask them to write down an equation that summarizes how to connect the mean of y to e and x. And some of these are students who've even had econometrics. Some of them are students who've never really done regression before because our psych introstats calls it ANOVA, and they don't know it's the same thing. Students come from a variety of backgrounds. And it's actually a real struggle for them. I think it's a real struggle for anybody to write down what equation this might be. But I've done this exercise too a couple times, and every time I do it, I end up writing in my notes for next year, this worked really well, students really got, right? So this is a struggle of a class, but by the end of it, they really understand what a regression is. You're trying to write down an equation that relates the predictors to the outcome, and you're assuming that equation is true. If you don't think the equation is true, then it's not a good model. So for the students, actually, part of the challenge is determining what terms you actually need in your model. Do you need X as a predictor? Do you need Y? It's not obvious to them you need an intercept. They get confused by the idea that the X-axis in this picture doesn't begin at 0. That's confusing for them, but they figure it out. Do you need an interaction? What does it mean to need an interaction? They have to figure out themselves that you need this term that involves e times x, right? And it's not obvious to them that you need that. And what I end up doing actually is once we go through this exercise in the class and then explain to them, here's the correct equation, which I'll show you soon, but I'm starting to see some responses coming in, show them this equation, and then explain exactly how it works, I end up repeating it on homework assignments and also on exams. And what this does, I find, is change the way that students talk about regression output. I find that students, when looking at regression, will talk about reparameterizing after doing exercises like this. We'll say, oh, you know, I see that race variable, but we didn't have to have white be the baseline. We could have used black as the baseline, and how would that have changed the model, right? They start to talk about the idea of an interaction not as an additional advanced topic, but actually the assumption of no interaction is a stronger assumption, right? No interaction is a special case of having an interaction. Assuming the coefficient for the interaction is 0 is a special case. And these students understand that, right? Even at this level. Whereas in most classes, first you teach simple linear regression, then you teach multiple regression with no interactions, then you stick on the interaction, right? But the students actually in this course figure out that you are making an assumption if you leave out that interaction term because they've had to grapple with this. The other thing I find that students understand after looking at this example is that using a linear regression at all, in other words, assuming that there is an equation that relates the mean of y to the other variables, is a big assumption. They've already seen regression trees, which makes different assumptions, and also strong assumptions sometimes. But they see that you cannot just blindly put things into regression, but rather the regression makes very specific assumptions about how the variables relate. I see a bunch of responses now, so I'm going to try to download these and see if I can make you a picture, because why not? This is what I would do if we were in class. Try to really do it. There we go. So here's a new picture that supposedly is going to have your guesses in it, although I don't think that worked. You can see a couple. Those I'm supposed to have light colored lines here showing what your guesses were, and the dark ones are the right ones. And again, either your guesses are all way off, which I don't think so, or the code didn't work, but that's okay. So the idea is I would show students answers here, right? If they actually managed to come up with a model that had the correct terms in it. Scrolling through your answers, I can see that you guys are generally close, although there's a huge range actually, right, to the correct equation, which is this one. Right, there's actually a very big range. So even because I can't show you graphically, let me tell you what I see is the intercept varying anywhere from 3 to 20 among your guesses. I see the coefficient for x varying anywhere from -2 to +4, right, etc. I see actually both the third and fourth coefficients, either positive or negative, depending on who is responding. So even in a group of statistics teachers, right, I see a huge variation here, and that's okay, because there's nothing actually that forces us to use linear regression, at least squares. So I want those students to see that just as we're seeing that. And again, I find that after they do this a few times, spend time staring at a visual, and again, we're emphasizing the usefulness of a visual, and trying to write down an equation for it, they have an appropriate suspiciousness, right, of linear regression, which is what I'm trying to teach them. The last example that I'll show you here is from the end of the course. One of the topics that I really like to include is missing data, again, because my goal is what I tell students when they're setting up for the courses is that after intro stats, you're not really ready to go do an internship over the summer and that uses statistics or data science. If you can get one, great. But really after this course, I'd like you to be someone who could be useful to somebody as a research assistant. And so at a point in the course when they've already had to do some wrangling with data that has NAs in it, and they understand the idea that you might have blanks or NAs or different, different types of non-response, we start to talk about the conceptual idea of missing data and what you might do with it. And so I show them this. This is fake data because I'm trying to show you the real answers that I used this particular fall. But you can see this describes a bunch of people, and then there's a blank at the end. And so I put them into groups and ask them to make guesses about that last blank. I'm not going to have you do it because this actually is a lot like the first exercise, and that's part of the point. So one of the things I want them to see is that when you are trying to fill in missing data, it's a lot like any other modeling problem, right? You take the information you have and you try to make guesses about what is not there. And so there's the student's guesses. There's no right answer because this is fake data. But what do I want them to learn? What are the morals of this particular story? They see really quickly that dropping missing values is a strong assumption, right? They see that. They understand they can't just do that without being very clear about the assumption they're making. The students also see, it's very obvious to them looking at that little example, that you can use the relationship between values to try to guess at the missing values, right? So you can try to see how the missing variable, which is political view, connects to the other variables in the data set, and they all use those variables, right? I've never had a student group ignore the other variables when trying to impute that missing one. And they see that this seems just like what we did on the first day, right? So then we talk about different types of missingness in a more formal way. We talk about how to actually implement single imputation. We do a little bit of multiple imputation. But I would say even at an intro stats level where you're not going to teach how to actually fill in the missing values, an exercise like this one gets the students to really understand what the implications are if you use a very simple approach like just dropping missing values. And that's what I'm really aiming for, right? So again, because this is a second level course, I'm not only trying to get them to understand why these challenges are hard, but also trying to help them be able to solve the challenges at any level, at least getting the students to see why this is hard and what the computer is trying to do when you run a regression, when you run some kind of missing data imputation software, when you type in t.test and it does a hypothesis test, or when you run any kind of model. It's trying to do the same things that they grapple with themselves. And again, I find that when the students are having to grapple with the methodological problems before I tell them the answer, they have a much bigger appreciation, not only for how helpful it is if someone else has come up with a method, but also how challenging that was and how many assumptions there are for those methods. And they're more interested in alternatives. I get a lot of student projects that use regression trees instead of linear regression because they prefer it once they've taken this course. The last thing I want to talk about just is how to assign groups, because I think this relates to the conference theme of engaging everyone. Of course, there's lots of literature out there in all fields about how to assign groups for people of all ages, but I want to tell you about my experience. My experience was very strongly that grouping the students by ability to the extent that I could discreetly was really helpful. So I wasn't going to take, the 4 students whose hands are up all the time and the 4 students who never show up and put them in groups with each other, right? That's too much. But you can take the students who are generally in the A range and make groups out of them, and the students who are generally in the B range and make groups out of them, etc. What I did in this course was at the beginning of the semester, the groups were random. As the semester went on and I got to know the students, the assignments, the group assignments, which were different every day, we had groups slowly morphed, right, to be a little bit more by ability. And from the students' perspective, it seemed like, I think that what it seemed like was that I was getting them to meet new people. So what did I observe? I observed that once we had ability groups, there were no longer students blindly writing down what others were doing, or at least many fewer of those students, right? So if you take a struggling student and put her in a group with people who already have a solid understanding, she just writes it down or types in her code or whatever it is. But that wasn't happening because the struggling students were in a group together and they had to come up with a response. And what I found is, often I would say, okay, we have 20 minutes and here are, A, B, and C, 3 parts of this idea, this exercise to work on. And the struggling students often only got through the first part, but they had an epiphany about it and they were really excited, right? They felt like they had achieved something, accomplished something in a way that maybe those particular students weren't used to while in a classroom. Whereas at the same time, the advanced students weren't sitting there bored because they had more to do, right? So the advanced students might get through A and B really quickly, but they were still working for the entire period, which I noticed was really different than what happened when the groups were more random. And the last thing that I really liked, this again relates to engaging everyone, is that as the semester went on and the groups became ability groups each day of class, the students were connecting with others to make informal study groups, and they were choosing the students I was introducing them to who were students appropriate for them to be matched with. So organically, on their own, the students were meeting other students who were the appropriate study partners for them. And I thought that was a really good thing. So thank you for Zooming with me. I did one office hour this spring where I Zoomed all by myself, and it was so sad. So I appreciate your coming. And I'd love to answer any questions or hear about what exercises have worked best for you. Thanks so much.
Thank you so much, Casey. I appreciate that. So I have a couple of questions who have come in. One was asking about the OkCupid data site. Some people had heard of some ethical concerns. Have you considered those when using that data set?
Such as data privacy or something else? So the data itself is confidential. So I bet the question's about something else. I would love a follow-up on that because the answer is no. Certainly the students realize that it's de-identified and appropriately, worry about that sort of thing, but no.
Okay.
But again, I'd love a follow-up. I'd love a follow-up because if there's an issue, I'd love to think about it.
Yeah. Hopefully that person will add an additional one and I'll read it out to you if that happens. So next question, did the students get frustrated not being able to finish the work in their ability groups?
I didn't find that, right? I didn't find that. And the reason is that I wouldn't ask the students to submit this work typically, right? So this was not part of a homework assignment. What I often did, this is separate from what this talk is about, but what I did is I had like quick survey questions at the beginning and end of every class that I used basically for taking attendance, and they weren't based on, the scoring wasn't based on the answers, it was based on whether you were present. So sometimes that's how this would be collected. Right, so before you walk out of class today, submit your guess at whatever, and they would do that in groups. And so there was very low stakes. So I didn't find that, and I think what I noticed is that the students seemed to feel more empowered because they'd actually answered some of the problems and understood them on their own, whereas those same students in a mixed group might have actually understood none of it and just written down somebody else's answers and kind of skulk out of the room. Yeah.
So just for clarification, by ability group, you mean people of similar abilities? Correct?
That is what I mean. I mean that I put the A students together and the B students, et cetera. And I like that a lot better than the random way. Again, I have a concern there about that being very obvious to students. I tried to make sure it wasn't. And if it was, I didn't hear about it on my feedback, which Wellesley students are usually very vocal. So.
Yes, usually. Yeah. All right. We have our last, oh, here we go. This is a comment about the OkCupid data. Yeah. The OkCupid data was scraped without consent from the site and posted publicly. So I think the initial scope, yeah.
Got it. That's interesting. So I didn't know that. I know that the authors of the stat ed paper had worked with somebody, I thought, at OkCupid to post that, but I didn't know that. In this course, actually, again, separate from what I'm talking about in this talk, I inserted data ethics for the first time because we have a new data science major, and it felt important to us that our data science majors were exposed to data ethics. But of course, we have no course on that, so we decided to stick it in the modeling course. So throughout my course, the students were discussing articles and thinking about data ethics, and I was learning about the topic for the first time. So that is good to know, and I will look into that. And I think it would be actually interesting for some of the students who've already taken this class to discuss. So thank you for that.
Yes.
Yeah.
Okay, so one last question. Did you come up with all the questions, or did you also learn them from another resource? If you had a resource, would you mind sharing it with us?
Yeah. So there's nothing that I'm showing you here that came from elsewhere. Most of these are things that I had developed over time and then realized this fall that I had to kind of pull out everything I'd ever developed and use it all. So there's nothing here that comes from elsewhere. I'm happy to, for these exercises to be used, which is why I'm giving these talks. Yeah.
Great. Well, thank you very much. Really appreciate you joining us today. And you definitely are not in a Zoom session by yourself.
Thank you so much. Thanks,
Yes.
Megan. Thanks, everybody.
Thank you.